So let's wish Dylan a very
So here I am.
to us.
Hello, or hey, as I believe they say. Although they say it with a J, and in Norway they say it with an I. Have I got that right? So yes, I met some of the Tretton team at LeetSpeak last year. Had a really great time, really cool event. I'm in town for Sweatug, which is happening tomorrow and Friday. And they said, if you're going to be in town, can you come along? We'll do a meetup. So thank you, everyone, for coming out. It's really good to be here. Really good to see you all here. This is me. I'm Dylan Beattie. I've been building websites since 1992. Like, literally, my first website, or the first page I ever put on the World Wide Web, was less than a year after the web was invented. I didn't quite realize what I was doing, but it looked like a lot of fun, and I kind of kept. And then the next day, I made myself some Webmaster business cards, and you know, the rest is history. I've been hacking around with distributed systems, software, websites, pretty much my entire career. I'm the CTO at Skills Matter, a company in London who do conferences some of you might have been to, Full Stack, DroidCon, IOSCon. We do a progressive.net, or ProgNet as we call it now. We also do training courses with all kinds of people on open source projects. Our thing is we try and get the people who created open source, and we say to them, do you want to come and actually show people how to use the thing you built? And that works pretty well. So we're in London, we're growing. I'm doing a lot of work with them at the moment. MVP, Microsoft, thank you, Microsoft. I run all my pet projects on Azure, thanks to them, which is pretty cool. And I run the .NET user group in London. So if any of you are ever over in London and you want to go along and meet some friendly nerds and have a beer and talk about tech, give me a shout. I know lots of fun people who would be more than happy to spend some time. Now, I speak English. It's the only language I speak even kind of vaguely fluently. One of the lovely things about working in technology is that I can travel all over the world, and everywhere I go I find people who will speak English to me, which I never take for granted because I feel like other people are the ones doing all the work. So I always try when I'm going somewhere to do like a little bit, just try and get a couple of useful phrases. So I've been using Duolingo to try and just, learn some useful phrases. Now, Duolingo's pretty good, but some of the things it teaches you are not terribly relevant. Duolingo has taught me to say in Swedish, "Du dricker min katsmjölk." Han är inte så dum som han ser ut, utan han är dummare. And sta inte nushonigen, han är från Norge. So I'm going to stick to English, if that's all right with all of you. Maybe next time. Now, I spent a lot of my software development career working for a company in London called Spotlight, who are basically like a LinkedIn, a recruiting platform for professional actors working in films and television and theater. And whenever we would do any work with an agency, they would always put the same clip art in the presentation that they pitched to us, which was this. The Greek theater masks, the generic, oh, it's a theater company, let's do the Greek masks. And, this is comedy and tragedy, happiness and sadness. And that's kind of the theme of the talk tonight. The talk is called Life, Liberty, the Pursuit of APIness, the Secret to Happy Code. And what I want to do is just talk about a pattern that I've noticed. I've worked on projects in my career where it looks like this thing is never going to work. You've got 2 or 3 people, really, really kind of audacious. Is anyone going to be able to do this? We don't know. No one's built an algorithm quite like this before, or a big data center migration, or anything. And you don't have a whole lot of budget. And after a couple of days, people are like, this is cool. It's working. And people start getting excited to come to work. And you see people high-fiving one another and this kind of thing. And in my experience, those projects tend to ship. And they deliver stuff. They create value. And I've also worked on projects that start really, really well. The ones where it's like, this is really important. We got plenty of budget, new equipment, new tools, all the hardware. We're going to host it all on cloud or Amazon or, all the stuff that you and your team have been like, I wish we could do this. And then within a couple of weeks, suddenly it's like, it's not fun anymore. And people are just like, are we still trying to get this to work? Are we still trying to get that to work? And the whole thing starts out with this really, really kind of positive proposition, and it fails. And those are the projects that end up becoming a death march. Like 6 months later, you still haven't shipped your 1-month prototype. And this correlation to me, I've never seen a good project shipped by people who were not happy working on it. And I've also never really seen, I've seen people ship the wrong product and have a lot of fun in the process, but I've never seen people who enjoy that collaborative process actually ship something that doesn't work terribly well. So I noticed this correlation. I thought this would be an interesting thing to start doing a bit of work, doing a bit of research into. Now, one thing I'm going to say at the beginning, this is not about mental health. This is not about anxiety and depression and all these kinds of things. This is about not being pissed off at work. That's it. That's the level. It's about kind of smiling and enjoying the stuff that you do. That's as deep as it's going to go. I'm not qualified to talk about a whole lot more than that. So that's one of the ideas we're going to talk about, is this idea of, you know, happiness and engaging people and making working on code bases a positive experience. Now, there's an idea we're going to talk about a lot, which is something called discoverability. Discoverability is a term that comes from educational psychology. Discoverability is the ability of a system for you to, or the way you can learn a system by playing with it. It's a system that rewards experimentation. It's a system that you can kind of pick up and you can push the buttons and you can see what they do. And you can try running little bits of code and you can see what that code does. And you can run database queries, you can see what that does. And so you can effectively, safely play around with the system, the environment, the platform you're working on, and discover for yourself what it is that it does. And this goes hand in hand with another idea which comes from educational psychology. There is a neurotransmitter in the human brain called dopamine. Dopamine is one of the two kind of happiness chemicals in the brain. And dopamine is the addiction chemical. Dopamine is the thing that keeps gamblers going back and having another hand of poker because they get this dopamine rush when they win. And you can also, dopamine is released when we solve puzzles. Has anyone ever had that thing where you're sat at home one night and you're coding on something, or you're playing Super Mario, I don't know, and just you have these little loops where every kind of 5 minutes you're like, all right, I'll just do one more bit. I'll just get this next feature working. And then you're like, I did it. And you're like, I should go to bed. And you're like, I'll just do one more, just do one more. And you go round and round and round. And every time you get it working, what's happening is you're getting this little dopamine rush in your brain. It's going, go on, you're a winner, do it again, do it again. And that is addictive, it's compelling, it modifies our behavior. But it also makes us good at learning things. People who are experiencing that dopamine rush actually form memories more quickly, and they can use that information more readily. So if you learn something by solving puzzles, the next day when you come back to it, you know the thing where, like, I mean, Super Mario was it for me. You'd stay up late at night playing it, and then the next day you could remember everything that you did to get to that point, and then you pick up from there. The knowledge and the things that you learned while you're kind of in that psychological state is stuff you can use very, very readily. So if we can create software systems that people can open up our code, they can start playing around and exploring it like they're doing Super Mario or something, and they keep solving puzzles and getting this little reward loop, we're actually going to build systems that incentivize people to learn them, to get better at using them, better at working on them, and that process of discovery is so positive it almost becomes addictive for them. So how could we do something like that? Now, first of all, I want to talk about this idea of something we call learning curves. Now, you know, learning curve is this expression we have in English. We talk about steep learning curves and shallow learning curves. And people kind of think steep learning curves are bad. You know, someone's like, oh, that project, it had such a steep learning curve and everything. So I've got some curves here. I got a blue one and I got a red one. And just kind of by show of hands, who thinks the blue curve is better? Yeah, we got a curve. Who thinks the red curve is better? Who thinks this is a really stupid question? You know, it makes no sense. A steep learning curve is one where if you work hard, you get good quickly. A shallow learning curve is one where you can use a system for a long period of time without learning very much about it. The steep learning curve is, you know, somebody goes home for a long weekend and they come in on Monday and it's like, I learned Haskell in a weekend just by working really, really hard. And the next day they're talking about monoids and type amplifiers and all this kind of stuff. The red learning curve is someone, they've been using Microsoft Word for 10 years, quite happily. They still don't know how to do a section break or a mail merge. Because, you know, there are tools which just don't incentivize that kind of learning. These are both fine. We can build systems that you can learn steeply. We can build systems that have shallow curves. What we want to watch out for is this. This is a localized peak, this thing here. And this is, well, let me give you an example. Does anyone here work with ASP.NET web forms? A couple of us must. There's always a few in the room. So ASP.NET Web Forms was this amazing technology that Microsoft created way back in about 2002, where you could drag buttons onto a web page and then double-click, and it would open up the code, and you could write the code that happened. And people got very, very good at building websites using ASP.NET Web Forms. And we had this toolbox of grids and repeaters and image controls and all these incredibly powerful building blocks, components. And then one day, your boss or your client would say to you, oh, can we put a streaming video player in this page? We're selling houses and we want to do like a virtual walkthrough. Can we put a video player in there? And you go into your toolbox in .NET and you look for a video player and it's not there because that component doesn't exist. And so you think, all right, how hard can it be? I can build a video player. I'm a serious software developer. And you start looking it up and you start learning all these things you've never seen before, like packet download offsets and lengths and buffering. And that's when you realize you don't know anything about building websites. You know how to use web forms. You've learned a set of abstractions which are not how the World Wide Web actually works. You don't know the underlying protocols. You've worked really hard to get up to kind of here somewhere, but now in order to get better, first you have to go downhill. All this stuff you've learned is useless now. That information is not, that's a localized peak. It's where you get up to here and then it's like, well, no, to do any better, you've got to go all the way back down and then all the way back up again, and then you can start the next level of your progression with learning this platform. And that is you go home from work that day, you're like, I've wasted my time. I hate software. I hate the internet. Websites are stupid. I don't like web forms. That's the kind of experience we're trying to avoid. Now, has anyone ever seen this how to draw an owl tutorial? It's really easy, right? This is step-by-step documentation how to draw an owl. So the first thing you do is you draw an oval for the head. And then the second thing you do is you draw oval for the body. And then step 3 is you draw the rest of the owl. It's easy, right? It's just 3 steps, 1, 2, 3. But people are like, okay, oval, what? Like, I don't get it. I don't get how you got from this stage to this stage. And you'll find the same thing occurs when you're trying to learn certain kinds of software systems as well. Because the learning curve we've created looks like this. It's like this is draw the head and the body, and then this is draw the rest of the owl. And we haven't given anyone any idea, how do you get from here to here? This is a brick wall. This may as well just be, broken. This is 2 separate things at this point. And it's surprising how often we get these brick walls crop up in software. You're following the README from GitHub or whatever, or you've installed the Node package or the NuGet package, and suddenly you just get, bang, error message, operation failed. What? And you go back to the documentation, and it says, simply install, and you're like, I did it, and it didn't work. What is this simply? It was simple when you did it, because you wrote the package. I'm trying to do it, it didn't work for me. Now, about 10 years ago, when people were still talking about alt.NET and this kind of thing, I was playing around with a thing called Castle Windsor, which is an IOC container. Anyone worked with Castle? Yeah, Castle is pretty cool. It's a good project. This was before Stack Overflow, so if you got stuck, basically you were on your own. So we used to follow instructions from blog posts. And I was following this blog post that said, this is how you do dependency injection. And I downloaded Castle Windsor, and I put it in my project, and I wired up all the DLLs. I pressed F5 to run it in Visual Studio. And I got this error message, server error, and I was like, okay, that's it, yellow screen of death. And I thought, hang on a second. Look at this error message. Like, look at what this actually says. So 1, looks like you forgot to register the HTTP module. Now, I love that so much because it's not saying you did a bad thing, you don't know what you're doing, you're an idiot newbie. It's saying it looks like you forgot. We got your back. We'll work this out together. It's friendly. It's kind of, colloquial. And then it says to fix this, and then it gives you this little chunk of XML here in the error message. And you follow the instructions that just came up on your screen at the point you got stuck, and you paste that into your config file, and you press refresh, and it works. And so 3 things happen. 1, solve the problem, dopamine rush. I'm going to remember that. And next time I'm probably not going to forget because I've had that kind of learning experience. 2 is I'm probably now going to stay up all night hacking around on Windsor, and by the morning I'm going to know how it works. And 3 is I have this positive experience. I feel like the people who built this care about me, and they want me to be happy and productive using the tool that they created. And that, a lot of people work in companies that have a user experience designer or a UX department or somebody who handles user interaction design. And it's very easy as developers to be like, well, I don't do user experience. I'm a database engineer. I don't do user experience. I make APIs. I don't do user experience. I'm a class library person or a DevOps person. All of us create user experiences. Unless you write code, run it, delete it, and no one else ever sees it, one day somebody is going to be the user of the thing that you are working on. If you're building a monitoring system, you're going to be on holiday and somebody else is going to get an alert that came off your monitoring system. If you're building a class library, somebody else is going to pick that up and try and plug some code into it. If you're building an API, somebody's going to be creating a mobile application that talks to your API. And all of these people are users, and the thing that they do with your code is a user experience. And we can do all kinds of things to make that experience better and more engaged for them. So you join a new company, new job, really, really excited about it, and you get it on Monday, and it's like, right, welcome, welcome to the company. Coffee machine is over here, toilets are there down the hall, here's your desk, get a website up and running locally. That, here's your passwords and everything. You think, I can do this. I know how to run websites. I'm a website developer. And so you go onto the GitHub organization and you start poking around. You see a repo called website. You think, that's pretty good. And you clone it and it's empty. There's no code in there. You say, okay, website 2018, maybe that's it. And you clone that one. That one's empty as well. You find one called website new. And you're thinking, they maybe don't know how to use revision control here. So you get website new and you go and look at that. And there's there's one packaged JSON file and a DLL. And eventually you turn to the person at the desk next to you and you say, Chris, and then Chris headphones off, and I'm really sorry to bother you, website running locally, where do I find the code? And Chris says, oh, the code is in a repository called sales. You're like, what? And it's like, yeah, the sales team, it was like their project because they built the first online checkout that then grew, so that's just where it kind of ended up. So you clone the sales repo and you get it up and running, and it comes up and it says, could not find C program files, my company, finance.reporting.dll. And you're like, and you type it into Google, but of course Google has never heard of my company finance reporting because it's proprietary. So you turn to Chris again, and headphones come off again, and you think, they're going to hate me by the end of the first day. You're like, where do I find the DLLs? And Chris says, yeah, right click, C drive, shared, everyone full control. Just, find whatever you need in there. So you go cherry picking DLLs out of this, and then you get to a point, where do I get a database backup and this and this? And maybe, if you're lucky and Chris is very patient and you don't run out of coffee, by the end of that first day, you've got the website running locally. If you're not lucky, you just end up with this. This is a real error message that somebody at Microsoft wrote for money. The operation could not be completed, unspecified error. And, somebody sat there at some point and was like, understood what it was the user would be trying to achieve at this point. And they're like, we're not going to give them any information. We're just unspecified error. This is lazy coding of the very worst kind. It's like, I can't even be bothered to think about why someone might have just had a bad time using my system. I'm just going to make life worse for them because that's what I want to do. This is bad. This is a really, really nasty way to build software, and it's a horrible experience if you're the person who's trying to use it. Let's try the same scenario again. You quit that job because they don't know how to use revision control and you can't find anything in GitHub. And so you go to work for the web agency across the street, and they get in and they're like, hey, welcome on board. The coffee's over there. The toilets are at the back there. This is Chris. You're like, hello, this is familiar. You sit down, and they're like, right, let's get the website up and running locally. And just as you're about to sort of dive into it, Chris turns and says, by the way, the website project is codenamed Applejack. And you're like, okay, cool. You go on to GitHub, type in Applejack, bang, there's a repository. You clone it. You press go. First thing you notice is it starts restoring packages. And you're like, hang on, that's not a public package server. That's an internal. That's NuGet.mycompany.com. Somebody has taken the time to get all of those weird finance reporting DLLs and put them on a local package repo so that anybody who needs to can just build the code and get all the dependencies they need. And then you hit F5 and it spins up and you get a screen which says, hey, well done, you're up and running, but we notice you don't have a database yet. Go and look in the repo you just cloned. You'll find a folder called SQL. That's where all our data definition scripts live. So 3 things happen. 1, you've solved the problem. Boom, dopamine, you're going to remember it. 2, you know now that there is an SQL folder in that repository which is full of database definition scripts. 3, you feel like you've made the right choice in joining this company. People have got your back and they care about you being productive. And by about, 12 o'clock, 12:30, you've got the website running and you've got the database loaded, and Chris looks over your shoulder and says, hey, it's looking pretty good. You want to come and grab some lunch? Or is it fika they do here? You want to come and get some fika? And, as you're wandering out, you say, what's with the Applejack thing? And Chris says, oh, we just name all our projects after My Little Pony. And you say, what? And he's like, yeah, they're just names, We have all these projects, and we wanted code names for the bounded contexts in our domain. Now, any sort of big organization you worked in, you'll get used to this idea that there are bits of code that talk to each other all the time, and there are bits of code that talk to each other once a week. And if you're familiar with the domain-driven design ethos or distributed systems engineering, you've come across this idea of bounded contexts. Like all of these things belong under this sort of conceptual container. And these things, so that's the sales system, that's the warehouse system, that's stock control, that's emails and marketing campaigns. Give these things names, because it is amazing. Once you give something a name, 1, you can start thinking about the behavior of your system in terms of conversations between these characters. And you can be like, okay, so Applejack is going to send a message over here to Cherry Blossom, and Cherry Blossom's going to send it to Shutterfly, and Shutterfly. And people will be like, why are you talking about ponies? And you're like, these are software code names. But also then you're like, well, we need to put documentation in the wiki. Cool, Applejack, new folder, there it is. Anybody comes along, they type Applejack into your wiki, they're going to find the documentation for this system. You want to send out, PagerDuty or notifications. You want to even give some of these their own identity on something like a Slack channel. You've already got the names for it. Names are a really, really powerful technique for encouraging discoverability. They're a way of helping people establish where the boundaries of the domain contexts are, and they're a very, very good way of making it easier to kind of relate to the systems that you're working on and understand how they hang together. Let's have a little bit of a history lesson. The first computer I ever got to play around with looked kind of like this. It wasn't exactly this, but it was very, very similar. And I'd wanted one of these for ages. This is a 286 PC with a megabyte of memory. And I'd been like, Dad, I need a computer, otherwise I'm going to drop out of school and end up doing drugs or something. I don't know, eventually it worked. He got this 286 PC and he brought it home, and I switched it on, and it kind of grinds for about a minute, and then it goes, A. And I go, hello, and it says bad command or file name. And I go, oh, menu, bad command or file name. It's like, help. I'm like, I didn't mean to be bad. I was really excited. I've wanted a computer for so long. Bad command or file name. Now, I'm not saying that you couldn't have a happy experience with MS-DOS 4.1, because what you could do was this. If you're happy and you know it, syntax error. If you're happy and you know it's syntax error. And yeah, that worked all the way down. This was the most fun you could have with DOS. But that, that black screen with the A in the thing, that's a brick wall. That's a, where do you go from here? And you just start going A, enter, bad command, B, enter, bad command, C, enter. And eventually you reach for the MS-DOS Programmer's Manual, which was a book about this thick, which was horrible. And that was it. That was the new experience. And we're talking about, a computer that cost £1,000, £1,500. So this is a really expensive piece of kit, and the initial experience of it is horrible. Now, the other computer that people were buying to do kind of creative and development work on around the same time was the Apple Mac. And when you switched one of those on, you got this little picture of a smiley computer that looked like the one you just put on a desk. And then it says, welcome to Macintosh, and it kind of sits and it grinds and buzzes for a couple of seconds. And then finally, when it's finished loading, you get this. And this was the first really successful mainstream window interface. This is macOS System 7. And, it takes you a couple of seconds to work out that you can move this thing around with the mouse. And then you're like, okay, what can I do? I can click on things. Okay, file, edit, view. Contrast this with that A on a black screen. There is stuff here you can do. You're like, this thing over here looks like a trash can. Maybe that's important. Okay, so we've got file and we've got edit. We've got, information. We've got things I can click on. Windows will open and close and stuff. Now, there's a classic mistake, which is people, they look at DOS and go, that's bad, and they look at this and go, that's good, and they think, well, how do we make ours even better? We do this. We put all the things on the screen. You know, this is, how difficult can it be to use Visual Studio? You just click on the things you need, right? And you type your program in the window here in the middle. And this is how you learn to code. Now, this is as bad as DOS, because it's exactly the same. It's like I have no idea where to even begin. If any of you are Visual Studio developers, you'll know that this thing here, you click probably 100 times a day. And this over here, which is the UML model diagram, you've never used once in your entire career. But there's nothing here that tells you that. You know, there's a kind of default configuration, but there's a pattern where people think the way to make software usable is to put everything on the screen so you can see all of it at the same time. What we need to try and do is develop systems that start out relatively easy, but they almost take the user on a journey with them, and they respond and they adapt as you discover that people are becoming more familiar with it. I want to show you a quick demo. This is one of my favorite examples ever of a piece of software that encourages you to get better at working with it.
Good morning. You have been in suspension for 50 days. In compliance with state and federal regulations, all testing candidates in the Aperture Science Extended Relaxation Center must be revived periodically for a mandatory physical and mental wellness exercise. You will hear a buzzer. When you hear the buzzer, look up at the ceiling. Good. You will hear a buzzer. When you hear the buzzer, look down at the floor. Good. This completes the gymnastic portion of your mandatory physical and mental wellness exercise. There is a framed painting on the wall. Please go stand in front of it. This is art. You will hear a buzzer. When you hear the buzzer, stare at the art. You should now feel mentally reinvigorated. If you suspect staring at art has not provided the required intellectual sustenance, reflect briefly on this classical music. Good. Now please return to your bed.
That's the opening level from, anyone know the game? Portal. Portal 2, actually. But Portal 2 is one of those games that just kind of drops you in. It teaches you how to play at the same time as it gets you into the story. So you wake up in this room, you don't know what's going on, you don't even know how to walk. And it just gradually feeds you hints, like use the mouse to move around. Okay, look up, look down, all right. And then you get keys, you know, press this key to walk forwards, press this key to interact with stuff. And so it's interesting and it's engaging and it's funny. It's scripted, it belongs within the game world, and it just forms part of that feedback process. There's another example which I saw not long ago, which I really, really like. This is Edge. This is, you know, Microsoft's new, forget Internet Explorer, this is the future now, browser. And the first time you open up Microsoft Edge as a web developer, you're like, okay, this looks pretty good, where's my stuff? And there's no inspect element, there's no view source, there's nothing here. And you think, hang on, I can't do serious work with this. And you start looking around and you think, hang on, what's this menu up in the corner here? And then you find F12 developer tools. Now, one, you notice there's no F numbers anywhere else. You just thought F12. I'm going to remember that. Subconsciously, F12 developer tools starts building this association. And when you it for the first time, you get inspect element and view source will now appear in the context menu. Now, have you ever had one of those panicked phone calls from like one of your family where they're like, the internet is broken? I clicked a thing and they broke the internet and now I can see the codes. And what they've done is this, they've just accidentally activated it. And if you do this on Facebook now, you get a massive red banner saying, this is a developer tool, do not paste anything here. People are trying to steal your passwords and stuff. Because we had this problem that we put view source and inspect element, which are power tools for professional web developers, on the same menu as back and print. And so it was so easy to click the wrong thing by mistake. And so what Microsoft did with Edge is they're like, well, let's pick the stuff that 90% of our users, and these are people who just, you know, they bought a Windows laptop in a store and have just taken it home. The stuff that they use all the time, we'll put that front and center where everyone can see it. Everything else will hide, but once you've actually gone up there and you've done F12 developer tools, we're like, all right, we get it. This is what it's about here. Let's put this up where you can see it. Let's look at another example of how we can do this in code. Now, you've probably all come across, whether you do .NET or Java or Ruby, anything where you're using a modern IDE, this idea of intelligent code completion, where you go console.color and it just pops up a list of options. These are the things you can do from here. And this is brilliant because it stops you having to remember everything. And it's a very, like I said, very, very powerful pattern that's used in a lot of modern development tools. But have any of you ever kind of gone to the level of writing your own intelligent code completion hints? There's something that I can never remember. I've been building .NET code since it came out, so coming up on 17 years. And one of the most common things that you do in .NET is you connect your code to a database. And you do that by saying SQL equals new SQL connection, and then you give it a connection string. I cannot remember connection strings. I just can't. They will not stick in my brain. And at this point, I'm stuck. I have to stop what I'm doing and go in Stack Overflow or whatever. So I built this little helper class called SQL.connect, and I pasted the documentation into the source code for that helper class so that at the exact moment when I know I'm going to get stuck, it just pops up on the screen, just for long enough to remind me this is the syntax: server, database, user ID, password. And then as soon as I close the bracket, it disappears. And most modern languages and IDEs allow you to do that. And all that you needed to do in order to do this, this little chunk of XML, this is C# and .NET, by putting that in my source code, Visual Studio knows that when I get to that point, I'm stuck, and this is the clue that I left myself to help me get to the next step. If you're building class libraries that other people in your organization are going to be using, or you're publishing open source projects, there are so many places where you can use these kinds of patterns to just, sit down, get somebody who's never used your project before and watch them play with it for 10 minutes. Find the point where they get stuck and think, what could I have put on screen at that moment that would have stopped them being stuck? And then watch them again, find the next point, find the next point. And you'll find there aren't actually that many points. Generally, we're pretty good at creating these smooth learning curves. It's just those bits that we miss because they seem obvious to us, because we understand, our mental model of what we're doing works for us. That's why it's our mental model. It doesn't work for everybody else. Now, this kind of stuff works really well when you know what someone is trying to do, and you have a pretty good idea of what your user is trying to accomplish. That's not always going to be the case. So I want to talk now about another user experience pattern, a thing we call signposting. Now, the World Wide Web is, I would argue, the most successful software project ever in history. And the World Wide Web, I think, succeeded because of three things. One, anyone can publish stuff on it. Two, it's very, very discoverable. You go on a web page, and back in the earliest days, anything underlined in blue, you could click it. And that got people used to this idea of clicking things and clicking things and clicking things. And the other thing that I think made it so overwhelmingly successful was the back button. Because somebody could click something, and if they didn't like it, they could just go back. It's like the ultimate undo. You can't do any damage here. And we started getting to a point when we invented online commerce of having do not press refresh, otherwise you will be charged twice. That's because we got people so good at this idea of, if it didn't work, just try it again. And that gave them the confidence to start playing around with unfamiliar websites. No one ever got on a website and went, I'm scared to touch this. I haven't read the manual. Because we're like, just click on stuff. What's the worst that can happen? And that's another really powerful pattern, this idea of signposting as a way of encouraging discoverability. So can we use that in code? Now, one of the things that I do a lot of kind of research and development on is building APIs. And we have a pattern in API development which some people call REST, and they mean it. Some people call REST because they're kind of doing some of it. Some people just call it hypermedia to stay on the safe side. But hypermedia is the idea that within your API itself, you almost make it as discoverable as a website or a web page. So this is a live demo of or it's a video of a live demo of a system that I built at Spotlight last year, where this started out as an internal tool we were using to test the stuff we were doing. And basically what it allows you to do is we have a discovery endpoint. And this thing lets you flip between a test, which is a sandbox environment, and a live system. And that discovery endpoint is effectively the first page of the manual. That's the page that says, look, we know who you are, and here are the things that you can do with this API. And this tool, this Browser Explorer tool, actually allows you to go in and interact with those in real time. Now, This, like I said, it started out as a diagnostic tool, then we shipped it, then we started realizing that actually as a kind of training tool and a way of getting people to experiment with our API. So this is an example of updating a record using an HTTP put operation. Results have come back through there in real time. And we started getting bug reports, and we'd be like, have you tried it in the Explorer? And they go and try it in the Explorer, and they come back and they're like, yeah, you're absolutely right, it's my fault, I had the thing crafted incorrectly. And that experience of, getting another team is actually as a team in Sweden. It was the Swedish equivalent of Spotlight, a company called Stagepool who were working with this. And their developers were like, this is really cool. We can just go in, we can click on this stuff, the links open up, we can submit requests, it's all sandbox, we don't need to worry about breaking anything. And so the feedback loop for them to get their integration points right was really, really tight, because we gave them this tool which allowed them to explore it, discover it, learn how it worked, try things out and see what the results of those were. So up until now, we've talked about building software. We've talked about if your user is somebody who is another developer, somebody who's working with your code to create more code. What can we do to create a positive user experience for that person? I also want to talk about the people who run your code, the people who are on call when you are on holiday, the people who are, the first one into the office when something has gone wrong overnight. So you ever had one of those scenarios where you get into work, you sit down and the phone is ringing, and you pick the phone up, you're like, hello, and they're like, the system is down. And you're like, can you give me a little bit more information? They're like, I can't give you any information, the system is down. The system. You're like, okay. You take someone's number, you're like, I'm really sorry, look, I'm just gonna have a look around, I'll call you back as soon as we know what's going on. And you hang up and the phone rings again, you pick the phone up again, and they're like, the system's broken. And you're like, yeah, we're aware of an incident, please let me take your details. And after about 10 minutes of this, you got 5 angry people yelling at you, and finally someone's like, look, do you need me to send you a screenshot? And you say, yes, please. And they send you over this. And it's just request timed out, and then your boss gets in and comes over and goes, the system's down, you're like, yeah, we know. It's like, how long is it gonna take to fix? And you're looking at, this is what you got. You got 6 angry phone calls, this screen, and the boss going, how long? And you're like, well, I don't know, request timed out. There's only about 10,000 things in our code somewhere that do a request. So let's just start checking them one by one. We can probably check one every 10 minutes. I don't know, we might be finished by lunchtime, we might be here till next year. This gives you nothing to go on. You have no control, no visibility on this situation. Customers are angry with you. The boss is angry with you. You're angry with them, because when people get angry with us, we get angry back. It's just human nature. The whole situation is just unpleasant, So let's run the same scenario in a different organization. You get in the morning, and this thing is on the wall. This is the monitoring dashboard. And the thing about the monitoring dashboard is that normally it is all green. Normally it is just numbers and big, happy, reassuring green tiles. And this morning you get in and you notice that some of the tiles have gone red. And you immediately think, okay, so what do we got here? So this is the spotlight.com, this is the intranet, this is the content delivery network. Okay. I'm pretty sure that if there's a problem with the CDN, then these 2 things will be compromised as well. So this is a good place to start looking. Before the phone has even rung, you've jumped on and you've sent an all-staff email saying, well, there's an incident, website's affected, intranet's affected, we think we know what's causing it, next update in 15 minutes. And you start looking into it, and sure enough, you go, okay, the certificate on the CDN has expired, because how could we ever have known that that was gonna happen? You renew the certificate, and bang, everything is back up. And we actually, these are real photographs of the dev office at Spotlight. And we discovered a whole bunch of things. We wanted this just because we wanted to see what our systems were doing. And what we realized is that putting this thing on the wall at a place where people walk past it every day makes all of them feel like they're part of the team as well. Because this is where people had to walk. The main meeting room is over here, and this is where everyone worked. So people would walk past this a couple of times a day, and it's like every time it's green, they just get this, our IT team is doing a good job. Which, how often in software development are you invisible until something breaks? Put a massive green TV up and keep it green, And the other things we started realizing, when something was red, people would notice, but they wouldn't be like, what the hell's the problem? They could see that we knew there was a problem. They could see that we were working on it. And they would do things like offer to go and get coffee. You'd be like in the middle of a priority 1 incident, and instead of someone hassling you about it, they'd be like, do you want me to run out and grab sandwiches? Or, do you need anything? The people coming around to, collect for birthday presents and stuff would be like, now might not be a good time, I'm going to come back later. And it really, just this one thing, this visibility created this culture where even when we had a serious incident, everyone felt like, we're in this, we're trying to fix something that has gone wrong. Let's help each other out and let's work the problem. Much, much nicer way of dealing with the inevitable things that are going to happen. Now, monitoring is a little bit like, the user experience design examples we looked at. If you take every single component and endpoint and service in any reasonable sized organization and put all of them on a dashboard, you're going to end up with this. And most people are not allowed to play with this because this is the flight deck of the space shuttle. And it has lots and lots of lights because there's about 6 million moving parts in a space shuttle, and most of them can go wrong. What we want is something that kind of narrows it down enough for you to know this is a problem and this is where you should go looking. Something more like this, something like the dashboard of a car. It's like, all right, this thing is the brakes, this thing is the fuel tank, this thing is the headlights, this thing's the electrical system, this thing means, be careful out there, it's icy or the roads are slippery. So it gives you just enough information for you to either go, everything is fine, I can get on with my day, or there is a problem here, I should start investigating and let people know that maybe something might not be working quite right. Now, monitoring is great. These kinds of ideas, you take systems that already exist and you plug endpoints and probes into them, and it took us probably a couple of months to get to this stage, building on top of a legacy estate that had been in production for 10 or 12 years at this point. So this stuff is not trivial, but it is really, really valuable. But this kind of monitoring is very much treating all your systems as black boxes. It's treating them as, okay, website, let's do a HTTP get to the homepage and see how fast it comes back. That's it, up or down, that's all we got. You're literally probing it as a black box. What if you took the covers off? One of the things that I loved about Star Trek The Next Generation, which was the Star Trek that I grew up with as a teenager, was they had the engine of the USS Enterprise out there. It was part of the set. They had this really cool set for engineering. And you kind of got used to this thing in the background with this blue glowing light on it. And if you ever saw this and that thing wasn't lit up, you knew what was going to happen this episode. Because there was a problem with the engine, which meant that the Starship Enterprise was crippled and it couldn't go anywhere. And, this is done by the simple expedient. They could have just put a wall there and saved themselves a lot of effects budget, but they didn't. They brought this thing out where people can see it. Can we do the same thing when we design software systems? Can we effectively build systems where we can take the covers off while they're running and actually get real-time live diagnostics? So I'm going to show you another demo. This thing called Nancy. Nancy is a application framework in .NET for building websites and APIs. And one of the fantastic things that you get out of the box for free with Nancy is the diagnostic dashboard. So we got a running system here. No, we don't. We got lumberjacks. There is one click in this video which never ever goes wrong when I'm rehearsing it and always goes wrong when it's plugged into a projector. That's it. So any Nancy system, you just go to _Nancy and you punch in a password that you've put in your config file and you get this. And this is like the Chrome Network Inspector, but it's on the server. And it's actually running live in real time. So you can go in there and you can see some of the most elusive bugs I've ever seen in my career have been when the code that's on the server isn't the code we thought we put there because a deployment had failed, but it had marked as succeeded or something. You can go in and you can actually just poke bits of code into your system in real time and check that the responses that are coming back are the things that you expect. Have you got the right routes mapped onto the right controllers? Are the right things taking the right data? And the thing that makes this really powerful is you can go into this thing here and you can enable request tracing. And then you wait a couple of seconds, and then you go in here, and every single thing that hit your API while that was switched on, you can literally see the details of that request. Where did it come from? What authentication tokens was it using? What were all the headers? How many firewalls did it go through? You can get that degree of visibility, and this isn't staging, this isn't sandbox or localhost, this is real. This is like your car only makes a funny noise when you're on the motorway. So you actually take the hood up and you look under the hood while you're on the motorway and see where the funny noise is coming from. As a way of rapidly triaging what the problem is when it's actually going on right now, it is fantastically powerful. But even with tools as powerful as this, the most interesting problems in software don't happen while you're looking. They happen in the middle of the night, which is why we need logging. Let's run a scenario here. It was the best picture I could come up with. I'm British, I have to have Monty Python in there somewhere. You get into work and, you know, the big red screen, or the phone is ringing, depending how mature your monitoring approach is at this point. And you're like, there's a problem, nothing's responding, the website is down. You go and you have a look and you're like, I see the problem. The main database CPU consumption has just hit 100%. Now, that tells us we have a problem. It doesn't tell us anything about how we got there. And without understanding how we got there, we don't know where we start looking to fix this problem. Maybe it's been doing this. Maybe this is what our CPU consumption over time looks like. Maybe it's been doing this. Or maybe everything has been absolutely fine for 6 months, and then you went, yeah, it's good, ship it, put it live, boom. Now, these are three very, very different stories. The same ending, database 100% and nothing's working. What about the time scale that this happened over? What if these three graphs, what if this is 10 o'clock, 11 o'clock, 12 o'clock over the course of a single day? You know? If it's the blue line, you're like, all right, at some point last night, something started consuming CPU, and it's been growing steadily since this morning. The green line, you're like, what are we doing every hour? What's the thing happening, you know, at each one of these strokes on the hour that has just been getting bigger and bigger and bigger? The red line, unfortunately, is probably that you shipped something that should have been checked just a little more closely. What if it's January, February, March? Suddenly, this tells a completely different story, you know. Like, this growth over time is, wow, we're getting customers. People are buying our product and using our system and this kind of stuff, you know. This one here, suddenly it's not every hour anymore. It's what are we doing on the first weekend of every month? Is that when we're like cleaning up all of the old GDPR records from our platform? What is that job look like? The red line, unfortunately, is still probably you've shipped something that should have been checked a little more closely. Only this time, you've blown away 8 months' worth of uptime instead of 1 day's worth. But without understanding that kind of historical context of how those numbers got to the state they're in right now when you're looking at them, you're still guessing. You're still like 100% CPU, maybe we've just got really busy. Do you know what normal traffic looks like? This is an actual graph from the main SQL Server box that ran Spotlight.com. And we knew what these curves looked like. We had a very, very kind of British-focused market. And so at 10 o'clock in the morning, all of the actors and theatrical agents and film directors in the UK would get into work, and they'd start looking for actors and sending out jobs and stuff. They'd all knock off for a nice late lunch. They'd come back, they'd do another couple of hours work, and then at 6 o'clock, they'd all go to the theater. You know, this is predictable. This is the correlation between our CPU usage statistics and the way the industry actually behaves. And sometimes we would get a massive spike first thing in the morning, and it would be like, is there a problem here? And the first thing you check is, did something really big just happen in Japan or Israel, which were other territories where people would use us to find actors? Because if a really big job was suddenly posted in one of those regions, we'd see a spike. Because for all those people, it was time to start work. If this thing didn't drop off at the end of the day, it meant something big was happening in New York or Los Angeles, you know? And so that would be the first thing we'd check. If we saw unusual traffic patterns, the first place you look isn't the code. The code is generally pretty good. The infrastructure is generally pretty good. What is the industry doing? You know, what's happening? And if we did get something that we couldn't explain, at that point we'd be like, okay, maybe we have an incident here we need to follow up on. But that was another way. All the other people involved were like, we're seeing some weird traffic. Did something cool just happen in Hollywood? And that way, it brings everyone on side, just like having that dashboard on the wall. It reminds them that we're actually all one team building this tool that is being used by people all over the world, and all of us kind of need to understand what we're doing with it. To make sense of these kind of historical things, you see a massive spike here. No one was watching when the spike happened. You know there was a spike. You want to work out what was happening when the spike took place. And that's why we need to talk about logging. So logging is your application saying, I'm doing this, I'm doing this, I'm doing this. And most of the logging frameworks that we use these days have this convention which goes back to Apache, the web server, where when you log something, you can log it as fatal, error, warning, info, or debug. Now, it's really important, particularly if you've got lots of people and lots of systems in one organization, to have some consensus about what these actually mean so that you know how much of a big deal it is when one of them happens. There will be places in your organization where an entire application doesn't actually do anything important enough to constitute fatal. The definitions that we instituted for working with these. Fatal means completely unresponsive, multiple users, immediate effect, stop what you're doing, look into it. Now, we had things like line of business reports that one of our employees would look at on a Wednesday. If that stops working at the weekend, that's not fatal, no matter how broken it is, because you can find out about it on Monday, you can dig into it, work out what the problem is, get it back up and running, and even if it takes a little while, you have that communication process. So there will be entire systems which are not critical enough to trigger a fatal error. Errors and warnings, to me, these are the things which will inevitably happen. The fallacies of distributed computing. Disk space is not infinite. The network is not infinitely fast. The network is not infinitely reliable. These are inevitable. What you are looking for here, you say you have a checkout where you can translate between euros and Swedish krona. And you do that by just bouncing a request to a remote API. It sends back today's exchange rate. One day, one time, it doesn't work. Is that a problem? You fall back to the last one. It's probably only 5 minutes old. 10 minutes later, still doesn't work. Problem? Well, probably not. 24 hours, you still haven't been able to get an exchange rate. At that point, you're potentially losing money or making more money because your exchange rates aren't accurate. 3 months, you could be in big trouble. But the point is, you do not want that one customer journey to be interrupted because you couldn't get a response off your API server. You want a graceful experience, and then you want to be able to proactively pick up that something weird here is going on. These things, to me, the value is in volume. It's in understanding how frequently they're occurring. It's like when you ride the metro, the Tivana, and there's somebody going to a costume party, and they're in fancy dress. This happens, you know. When this happens, this is interesting. You know, this is like something here is going on. There is a story here that we need to go and dig into to find out what the story behind it is. Info. Info is everything's fine. Yeah, the application started, application shut down, we recycled one of the nodes, these kinds of things. Now, the reason why I think info is so valuable, going for the weekend, you come back on Monday morning, there is nothing in your log files. They're completely empty. There's two scenarios here. One of them, you've had a perfect weekend. No errors, no warnings, no fatal exceptions. Literally nothing has gone wrong for 48 hours. What's the alternative? The logging infrastructure shut down. It failed, you know. You just haven't been logging because the logs are broken. And how are you going to know? Because the logs will log that they're broken in the logs, which isn't working. So info is the thing where you're like, no, we were actually up all weekend. Look, we got info messages every 5 minutes, you know, routine heartbeats and health checks, and we can see our monitoring traffic and stuff. We just had a really quiet weekend. Debug. One of the best habits I think we can get into as developers, when you're working on a system or you're doing some diagnostics, sooner or later you'll find yourself doing like a console.log or console.writeline. You just want to get some state out onto the screen so you can see what's going on. Just get into the habit of using log.debug for those kinds of things and leave them there. Because at that point, when you were working on that system, that information was valuable to you. When you'd ship it to production, you can switch it off. This is fine. Log all the things, all that stuff which has value at the point you're working on it. Now, you're thinking, but that's going to be lots and lots of things. Like if we literally log method entry and method exceptions and you know, return values and everything, are we really going to log all this stuff? And yes, we are. And the reason is you can switch it off and it doesn't matter. And one day you are going to be trying to fix something that only goes wrong at 3:30 in the morning when everybody is asleep. You can never reproduce it in local, never reproduce it in staging. You can't get anything out of the monitoring for it. At that point, you are going to want to be able to just flick that switch. You're going to want to be able to flick that switch and switch on that debug logging on production and see exactly what was going on at the point this thing blew up. I think a lot of the confusion about these is because they gave them the wrong names. Log fatal should have been called Wake Me Up at 4 a.m. on a Sunday. You don't write that in your code unless you understand what you're getting yourself in for. Apologize to the user and raise a ticket. Log.warn should be log.tell me if this happens 1,000 times. Log.info should be log.everything's fine, just checking in. Now, the reason we don't switch debug logging on all the time is that it does create an awful lot of traffic. So that one should be called log.fill my C drive with stack traces. Because that's basically what these different levels mean when you use them for real on a production system. So let's recap. Let's just go over the rules of happy code. Applejack, My Little Pony, naming things. Names are a really, really powerful way to encourage discoverability for your systems. They work brilliantly for search. They work brilliantly for code names. They work for distributed systems and message passing and Slack channels and emails and integrations. They don't need to be cool names. They don't need to be marketing names. You can literally pick anything. Let people name their own projects. It's a great way of encouraging the sense of ownership. And use them, Have your names. If you want to know what a system's doing, punch it into the monitoring dashboard. There it is. Applejack's green, Shutterfly's green. Oh, Cherry Jubilee is red right now. There might be a problem. Learning curves. Steep is fine. Shallow is fine. Watch out for the dead ends. Watch out for the roadblocks. Watch out for the owl. Get someone to sit and use your system for 10 minutes and see the points where they get stuck. And don't just go, oh, let me fix it for you. Sit there on your hands with tape over your mouth going, I need to fix that, I need to fix that, and then fix it. Put in those clues. If you're writing error messages, do this. Put as much stuff as you can into the error message. I had a project I was working on a while ago about parsing, EXIF data from digital cameras that tells you where the camera was pointing and whether it was this way up and all this kind of additional metadata. And there was one chunk of JPEG files we had that were giving back data that was literally impossible. And someone's like, what do we put in the error message? And I said, put in the error message that the camera is giving back data that is impossible. Like, don't just say unknown EXIF code. Say, hey, there are only 8 documented values for the camera orientation in EXIF, and the camera you're using has given us back the number 11. This is outside the scope of the spec. Do you know what it means? Share this level of detail. Give everything, because 6 months later, you're going to forget what you were doing, or somebody else is going to be working on this, and that data is going to be so, so valuable. Don't do this. Like, that is just the most unhelpful dead end. It didn't work, and we don't know why. I mean, it's almost as good as the best one ever, which is the operation could not be completed. Error was operation completed successfully, which is another one you get from time to time. Signposting. Think about if your user is at a point in their journey with your application where there's a couple of things that might make sense at this point. Those are the ones you share with them at that moment. Don't go, hey, here are our 1,001 API endpoint capabilities, but also don't go A and expect them to work the rest out for themselves. Think about information hierarchies. Think about taxonomies. Think about how to organize the features and the capabilities you're providing in a way that will reward this process of discovery. Put the engines on display. Take the covers off stuff. Build your systems with, metaphorical hatches so you can plug your monitors into your homepage and see how fast the JavaScript is right now without relying on CDNs and stuff. Think about how to create better transparency and share that with your whole organization. Put it up on the wall. Get everyone involved with it. This is what we're doing right now. By the way, that line there, that's nothing to do with the website. That's the number of incoming phone calls we've got coming from Los Angeles at the moment. Think about what you can do to give people that insight into what your entire system and your entire set of platforms are doing. And the golden rule to rule them all, we're all creating user experiences all the time, even if you think you're not. If you're writing code, one day somebody is going to be using your code, and it is up to you whether that person is going to have a bad day and go home grumpy, or whether they're going to have a great day or they're going to go home with a smile on their face. So all of us can do that and put more smiles in the world. Thank you. Questions? Do we have questions? Or have we achieved complete enlightenment?
That video you showed in the beginning,
Yep.
is that available online? Or
The flat screens video
Yeah.
is on YouTube.
Oh.
Yeah, just go youtube.com/Dylan Beattie is where I keep all my silly fun stuff. So, yes,
I have a question.
yeah.
Have you worked in places where you've seen examples of this approach being applied in a structured way, almost in terms of applying it in a sort of test-driven development way, discovering?
You mean in terms of almost using like a red-green refactor approach to monitoring?
Not monitoring, the concept of the whole.
To the whole discoverability thing. Not really, because a lot of, probably just because I haven't worked in those kind of places. I don't know, I suspect they probably do exist. I have seen, so one thing that I have seen teams start to do is to almost kind of use monitoring as part of their development process. So they are taking these ideas about monitoring and discoverability and incorporating those into the feature is ready, but it's not actually ready until we've got a green monitor saying that it's still ready. There's a great talk, Pete Mounce, a friend of mine who was working at Just Eat for a while on their infrastructure automation. So Just Eat were a really interesting company, the big takeaway company, because at 8 o'clock in the morning, nobody is ordering pizza. So they need like 3 web servers. And then at 8 o'clock in the evening, thousands of people are ordering pizza. So they need like 200 web servers. And then at midnight, everyone stops ordering pizza because all the pizza places close. So they had this, really, really dramatic spike. And, one of the things that they used to do was DOS themselves in production by literally running 30% of the traffic through their production platform was their own tests and their own monitoring traffic. So one, they load tested themselves all the time. New features got load testing just as a consequence of being shipped. But also if they had a problem, they could switch off all that traffic and suddenly they had 30% breathing space and 30% headroom while they worked out and investigated what the problem with it was. So there are some very, very interesting approaches to how you institute these kinds of ideas and how you promote them and how you deploy them along with your systems. In terms of discoverability and the sort of stuff as a structured, I guess almost a methodology for building software, I'd like to think we're not there yet. And that it's coming. I know different people are thinking about elements of this in different ways. But if anyone's doing it right, I haven't worked with them and I haven't seen them talking about it yet. Unless they're in the room, Any other questions? Cool. All right. Well, thank you very much.
Thank you everyone for coming, and thank you, Dylan.
My pleasure. Thank you for having me.
There's some pizza, some drinks left if you want to stick around for a while. We will be here until about 8 o'clock, so feel free to join us. And you can see Dylan at Svetuk tomorrow, right?
Yeah. Yeah, I will be.
Got the ticket there.
No, I will be talking about NT for the .NET Core, 20 years of continuous improvement at about 11 o'clock in the morning.
Anyone up for that? Know where to find me.
If anyone wants to see video of someone installing Office 97 in 33 seconds, come to that talk.
Otherwise, thank you for coming.
Yeah, to get some screenshots, I had to install Windows NT in a virtual machine on this, and it's so fast. It is. Huh? 11. I think it's 10 past 11. I should know that. I know it's tomorrow. It's not the first one, and it's before lunch. So yeah. Svetag. At the conference.
Thank you.
Thank you. Hello.
Hi, you're part of Elbrand, or
I have
spoken it before?
been to several of their meetings.
Fine, okay.
I haven't spoken there. I work at the company where they host their meetups.
Yes.
But also my team at Skills Matter are all Ruby developers because that's what our stack is in. So I've stood up at Elrug many times and gone, hello, come and work for us.
Okay, yes,
So,
that's fine.
yes, if you've seen me at Elrug, yes, that entirely happened. So, how you doing?
Yes, good.
Right, let me
Talk was
just...
very interesting, thank you.
Thank you.
So, yes. I'll let everyone else ask the questions. I was just
Hey.
thinking, I was sitting there racking my brains, being like, thank you.
Yeah, I'll just jump in.
Hey.
I have to run to the airport. Yeah.
Cool. Well, thanks for coming by, dude.
Thanks
Good
for
to see you.
coming by, and yeah, I wish I could hang out and drink. You know what? I had a gift, but I figure out it's not the most thought-through gift because you're probably not checking in.
I am.
You are?
Well, one, I've got a guitar and stuff for tomorrow night, but I also have enough kit to go up to Kiruna and stay in the ice hotel, so I have a big bag. So the gift is absolutely perfect.
This is a Swedish Christmas drink. It's weird.
Okay.
Have you drank it before?
No. Swedish Christmas drink.
Swedish Christmas drink.
Brilliant.
Okay.
Thanks,
well,
man. See you soon.
Yeah, I'll.
Here or there or in a neutral country that will...
I actually have one thing because we're doing like this big company retreat thing soon,
Yeah.
and I would like to talk about possible ideas I have. I don't know if you can do it or you can like point me in the right direction of finding someone who can do it. It has to do like the scope will be surviving the legacy code apocalypse. That'll be like the theme for the conference trip.
I wish you'd seen the talk I did at PubConf last week.
Is it recorded? No.
No.
Well, thanks again.
I'm very risk manager. You should be.
Yeah, let's put that out of the way.
I was thinking one question.
Yeah.
It was like the fatal era.
Yeah.
Isn't it the status of the computer server? Do you use file